Good afternoon, everyone. So, welcome to the online event Enabling Sustainable Building Design through BIM. And I hope my voice is clear and you're able to view
Yes.
my screen. Yeah. So, following the program details, so we'll quickly have a small audience poll, then we'll have the session by Mr. Chakreja and then Mr. Ashish Rakheja, and so on. And in the end, we'll have the question answer session. So I'll just quickly launch the poll. I would request you to please, everyone, please take part in the poll. It's going to be only for 2 minutes. So I'm launching the poll now. So you must be getting the question, do you opt for a green building rating system for your projects? So I would request our audience to kindly take the poll so it will give us the idea about the current exposure to the audience for the green building rating system or the sustainable design. So right now, 61% have polled. I would request other guys also please just take part in the poll and then we can just finish it off. Okay. So I'm stopping the poll to see the results. So I'm sharing the results. So we can see that 18% have never tried the green building rating system. 87% have tried in some projects. So that is a good news. So we have the audience, they already have the idea and they have used the green building rating system for their projects. Okay, thank you. So we'll start with the webinar. So opening session will be by Mr. Chakresh Jain. So Mr. Jain is chairman of board at Capricorn Technologies Private Limited. He did architecture from IIT Kharagpur and started his AutoCAD training and consultancy just after graduation. He was initially focused on application of CAD in architectural design, but soon moved into partnership with Autodesk and expanded into software solutions for entire building and infrastructure industry in the name of CAD Studio. Mr. Jan served as founder and CEO of CAD Studio for over 25 years. In 2013, CAD Studio merged with three similar Autodesk partners and formed Capricorn Technologies, which is now a leading technology provider for building infrastructure, manufacturing, media and entertainment, education, government, etc. Capricorn has been consistently recognized by industry and partners by various awards. A highly respected voice in AEC industry, Mr. Jain is actively engaged in various positions in IIT Kharagpur, Alumni Association, Pan IIT Association, and PhD Chambers of Commerce and Industry. So now over to you, Chakre sir. I'm stopping my screen so you can start sharing.
Yeah, thank you, Farhad. Let me share my screen. And if you can just confirm if my screen is visible.
Yes, sir, it is visible.
Okay, thank you, Farhad. And thank you everyone for attending our this webinar on sustainable design. In fact, since the lockdown happened, we have been conducting series of webinars around BIM, and The advantage which we could get now is like now we could run many more. Earlier we used to run all physical events and where the participation typically used to be only from the local city. But now we have a big advantage that we are able to bring participation of both our experts as well as the attendees coming from across the country. And that's exactly what we are also doing today. So so I'll just take two slides about ourselves. And as Farhad just mentioned that we've been into this for more than 30 years. And with all the years of effort, we have won more than 20,000 customers like yourself across the country. And we are present in 10 plus location. And we are a team size of about 300 people. Of course, slightly less today due to COVID. So we are Autodesk partner, but apart from Autodesk, which is our biggest partnership, we are also partner with whatever you see in the dotted line, which are all construction centric companies, and we are partner with them. So I'll not talk much about that, but let's look at why this today's event. And we all been hearing so much news about fires in various forests, whether it's in Amazon, whether it is in Australia. And basically, we all know that our entire earth is burning today. And what's the reason for that? And we all know the biggest reason is we as a human being. And if you see in last 12,000 years, look at the exponential growth of human population which has happened. And today we are already about 7.7 billion people on the planet Earth. Now, if we get into a little bit more closer, let's say last 50 years, and of course, India and China are the two most populous countries. And you can see in last 50 years, we have more than doubled our population. So as a country, our population has been growing very fast. But not only that, another big problem what we are seeing is look at the urban population. So in the last 50 years, you can see now the entire population growth is not happening uniformly across the country, but it is moving in the urban. So what does that mean? It means that as we need to provide a roof over each and every head. And what does that? So these numbers may not mean much to us, but if you start translating that into construction industry, today we are supposed to construct almost 800 housing buildings. I'm not talking about units, 800 housing buildings per day. That's the kind of pressure we have today. So on the one hand, we have a growing population where we need to provide accommodation for them. But on the other hand, we need to have a very sustainable earth also for ourselves. But it throws a lot of challenges to us. Now, the first challenge, which of course is very well-known challenge, is that in last 50 years, 60 years, we see the productivity in our construction industry hasn't gone up. So so that's one big challenge. Second challenge is today our customers also expect best of everything. Now, before industrial revolution, we used to have very good aesthetics and design. And with industrialization, we could also produce things which were very functional, affordable, and we could produce them into mass. But today our customers are expecting everything from us. And with both of these things put together is the current challenge we have. And I'll not like to talk about the solution, but we have a panel of experts participating from across the country and some of the best people available in the country on this. So let's hear from them. I'll pass on my baton to them, and so that they will talk about that. How can we have a balance between a sustainable plus what is required to provide a roof over each and every head in our country? So over to you, Farhad.
Thank you, sir. So
I'll stop sharing. Yeah.
So, our next speaker is Mr. Ashish Rakheja. So, Mr. Ashish Rakheja is partner at Aeon Consultants and has a postgraduate degree in thermal engineering from IIT Delhi with over 28 years of work experience. He's a seasoned consulting engineer who has designed over 2,000 projects, including hotels, airports, hospitals, retails, residential, commercial, high-rises, and industrial projects. Mr. Rakheja specializes in high-performance buildings and has been actively involved in leading design activities of electromechanical services for 10 net zero energy buildings and over 60 platinum rated green projects in India. He is spearheading the green building movement in India in capacity of roles as chairman technical committee of Indian Green Building Council, that is IGBC, and Mr. Rakheja is also a board member of ASHRAE USA. So over to Mr. Ashish Rakheja. So I'll just stop sharing my screen, sir. You can share your screen.
Thank you, Farhad. And can you see the screen now?
Yes, sir.
So thank you again. Namaskar, everyone. And thank you, Chakreshji, for a wonderful start and the initiative that you have taken from Capricorn. It's a great way to bring the professionals together, and this learning platform, the sharing and the learning platform that you have created is truly appreciated. I have been listening to the past talks also, and I'm happy that today I have the opportunity to speak here and share this platform with Millie and Priya. So thank you again. You also very rightly spoke about the amount of construction that is coming ahead. Well, I am a firm believer that India is going to build and build a lot. We have to become not even a $5 trillion economy at some point of time. With the kind of population we have to become much, much larger. And the construction industry will play an important role. Many of us at this point of time in life may not like to believe that construction industry has a bright future, but that's not going to be the case. This is all a small pause that we have currently, and things are going to get better for sure. So I pray that everybody is safe at this point of time, and please take care of yourself. Going forward, I just want to, the topic is amazing. It talks about enabling sustainable building design through BIM. Now, BIM is a very large word, building information modeling. And somehow BIM has always been regarded as just a tool, a REVIT drawing or a 3D drawing. But it's a much larger tool that we are talking of. We are talking of the information being modeled. And there are many aspects of it which is being practiced in isolation by the experts. Let's say the green building consultants do it in their own manner, and the engineers are doing it in their own manner. But at some point of time, they need to come together. And as they come together, that's where the integrated design process come into the picture, which is what the future is all about. Before I go forward, I just want to say that I'm part of a electromechanical and sustainability firm. That's what E.ON has been. And that is actually a strength because as an electromechanical engineers, we had the opportunity to design many buildings, many large buildings, doing the electromechanical systems there. And we also had this opportunity where the green building team of ours were working on sustainability assignments. We soon realized that the importance of marriage between the two. And that is where the whole concept of Vikalp came into the picture. Vikalp is nothing but an alternate design process, which comes down to the integrated design only. And that's where we came on to the idea of digital twins. It's a way that we've been talking about simulation building performances, but I look at it that we are actually creating a twin of a building. It could be an existing building, it could be a new building, and that's where I look at it as one of the applications of building information modeling as it goes on. So I'm going to be talking about the aspects of it in building design today, how it is being deployed. And I'm going to present various case studies to you, short one, since the time is only 20 minutes. We got eminent panelists ahead, speakers ahead. So I'm just going to show you small case studies. I normally give this presentation out over 1 hour. So I have condensed it to cover the essence of it. Now, we all know that the world is moving towards net zero assignments and net zero buildings. This is the future. Whether we achieve that in 2030, 2035, it's a matter of time. But the building codes across the world, including in India, are moving towards net zero performance, be it a net zero energy, be it a net zero water, be it a net zero waste, or it could be net zero carbon. So it's a shift which has started taking place. And as we are moving towards that, it is important that we optimize the building design before we deploy the renewables. It will be completely an incorrect way to go, where we look at a conventional building and use the brute power of renewable to make it a net zero energy building. That will just be the wrong way to go. And that's where the importance of taking care of passive elements of a building design, active measures, integrating the two, optimizing the building performance, and thereafter applying the renewable come into the picture. And that's what this famous energy triangle that most of us refer to talks about, that if you look at a conventional building, it has a base, energy base, which is such a large base, and to offset it with renewables would mean a huge investment in capital cost and may not make it viable at all. When we are able to bring that same base here by designing correct active and passive measure for the same building, making it net zero performance or near net zero performance becomes a small thing and becomes a much easier challenge to deal with. Today, we see in the market, in the industry, the clients are becoming quite aware of it. It's been already about 20 years of the green building movement in India. We are one of the largest, if you put together all the green building councils that are doing work in India, I think we are amongst the largest today in the world, maybe the second number, but the amount of green footprint that we have is really commendable, and it's all set to grow. Today also in the poll, it came out that many of us like to look for green buildings. The clients today have become so demanding, and we find requirements coming from them in terms of the building performance being optimized. I'm just putting forward one of the projects that we got involved, where the requirement from a client was that to bring down the heat gain from an envelope to less than 1 watt per square foot. Now, how do you quantify such a thing? They of course wanted 100% daylit space, as far as possible, more than 80% daylit. They said zero glare, and it is only the envelope that performance that they're talking of. And this is where the things like the tools that are available to us, that are available to the engineers, that are available to designers become important. Like a simple case, we had these 3 buildings on this project where the glare component was very high. The 2 of the buildings, we had the glare still under control, but in the building C, as you see there, the glare component was very, very high. Now, how do you take care of it? Obviously, we have been talking about putting shading devices, we've been talking about the various glass selections, and all that is possible to be done before you physically construct the building. I'm going to show you more examples in these areas where these tools are being deployed at this point of time. Now, here we are selecting the right glass typology. It could be a darker glass, a low VLT glass, to a medium VLT glass, to a high VLT glass. How does the glare coming inside varies? How does the daylight performance changes? What is it that we are looking for in terms of performance? All that is something which can easily be determined. Going forward, there's a double skin facades being talked about. There's something called a parametric modeling, which is now being practiced and being adopted in India, using the shading devices, active shading devices, passive shading devices on the building facade. Using these tools, one is able to find out a right kind of a shading device which balances between the daylight, balances between glare, and also the energy. A lot of time I come across questions that when you've got too much daylight coming in, are you not looking at the energy also consumption going up? So there is a trade-off that we have to do, and these tools help us to do a right trade-off in the building design. And you can see here the kind of results one is able to get from there, the exact results, and we are able to get down the glare and the daylighting under control, and then get into the energy performance. Since in this case there was a very specific requirement that the heat gain from the envelope should be less than 1 watt per square foot, which is typically about 25% of what a conventional building is all about. Using tools like if you are increasing the thermal, if you increase the thermal insulation on the wall, how does the energy performance is coming down? How the energy consumption is coming down? Looking at the insulation on the roof, finding out the right insulation thickness on the facade, on the roof area, looking at the fenestration U value, that means the glass U value, looking at the shading devices performance. All of that could be studied. This is how the various 10 options were worked out for the same thing, for the same facade design, and whichever made more sense at the end of the day economically, as well as meeting the performance parameters, get picked up. There's another great example that we worked on, a basement. Now here the client was very specific that they wanted a daylit basement, and they said if you could make it in which we require lesser ventilation fan, mechanical fans to be used. Today we make millions of square feet of basements. We require megawatts of power in order to run the ventilation fans. Now in this case, a very simple example of creating 4 large cutouts around the building gave us about 50% daylit basement out there. Suddenly we found, when we were looking at the CFD model of the same basement design, we found there were natural ventilation traces that were started coming in. Optimizing that design further, using the tools, working closely with the architect and designer could get us to about 85% daylit basement, making it practically artificial light free in the daytime. And look at it, we could avoid the mechanical ventilation altogether because we had very strong natural wind flows which are happening, which were meeting the National Building Code criteria of the natural ventilation and effective natural ventilation. Today, the wind is being talked about as a thermal comfort tool. We have projects that are coming up which are high street projects where they talk about, especially the retail application, where they talk about outdoor thermal comfort. Now, this is a retail project that you see out there. With everything, only the shops are air conditioned and all the common areas are open to sky. If you see here, an active CFD model of this will show you the studies being done on this project, looking at how the wind is flowing through. Now, mind it, all the areas in between here, the common areas as you see here, they need to be well ventilated to get a thermal comfort out there. But if you look at the wind model, it is completely avoiding flowing in between this common area or the atrium area, and is likely to cause a lot of discomfort. Improving that thing using, again, the simulation tools and coming out the various suggestions. And you can see here in the end, how was it resolved in order to make sure the wind is flowing correctly and studying these things. So you can see how the wind is passing through. And then introducing water bodies, working closely with the landscape consultant. And that's how you see the integration of various disciplines and the streams coming together. Today, this tool is being very actively used for energy optimization also. And this is a classic example of a building which was very well designed to start with. We had an air conditioning load of about 230 square feet per ton. And it was like a hotel menu card. When you go to a restaurant, there's a 20-item menu card which was presented to a client, where it said that step by step how we could make the same building from a 232 square feet per ton performance going to 534 square feet of area being taken through 1 ton of air conditioning. The air conditioning became less than half. The client also had the advantage of seeing what we call a capital cost reduction, a capital cost spend against each of the item, and a reduction in the annual energy which is coming out of it. And they can make an informed decision in terms of taking which example suits them the best or which strategy suits them the best. And looking at even the lighting optimization. Today we have a lot of interior offices that we work on. They're high-end interior, they're good interior offices, good lighting solutions that you work on. Using these tools to finalize look at the kind of lighting pattern that is going to form. Like what you see here, one of the common areas, the interior designer had used these suspended lights, and this is the kind of pattern they are forming. Now, is it right, wrong? It's something that an interior designer can look at it and determine, is this something that is the design intent? Looking at the watt per square foot which is being consumed in terms of the lighting energy, you could determine it earlier. One of the cabins, you can see the performance out there. A big patch is being formed out here, which is not only leading to energy wastage, but is also going to cause discomfort to the occupant inside. So this is something you are able to determine. One of the great areas that we worked on was indoor air quality improvement using the same digital twin process. It's a hotel design in which we had it's actually a 5-star hotel in Delhi, and we had a treated fresh air being supplied to the room and some exhaust going out from the toilet. The exhaust air quantity was larger than the supplier, the treated fresh air which was being supplied. Normally, that is a design which will be acceptable to everyone. But in this case, what we found out was, we are talking of IAQ where the PM 2.5, particulate matter 2.5 was a criteria here. Now here, because of the negative pressure that we created in the room by doing more exhaust than the supply, we had the movement of the particles coming from the building facade, because building facade always, it cannot be a completely airtight thing. By adjusting the pressure balances, by doing the air balancing there, one could ensure that the rooms are under positive pressure without allowing the PM 2.5 particles or the larger particulate matter to move inside to get ultimately the result you are looking for. And today, this hotel proudly displays their air quality outside on the at the reception area. Using a fire and life safety application, where you see here a building where a fire has been generated there. Here, the requirement was that we had a mechanical fresh air fan, which is sort of throwing in the makeup air, and then we have this exhaust which is happening to the ceiling space. Now, in case of emergency, when the smoke is being generated, we are able to extract the smoke out by a mechanical fan supply and a mechanical fan for exhaust. There's an energy concern with it. There's a capital cost associated with it. So what we here did was we looked at two aspects, in which one, we looked at the way there's a mechanical fan which is operating. There's a fire which took place. What is the kind of smoke buildup which is happening in this case when we have a mechanical fan for supply and a mechanical fan for exhaust? And in a second case scenario, what we also did was we looked at openings on the facade, where at every 10 meter there's a motorized window, and that window gets actuated by the fire alarm system. It opens up, and there is no mechanical fresh air fan now. It's only mechanical exhaust air fan. In fact, we found this to be better in performance, and also the capital cost, one could save crores of rupees for the client, because this is a tall building requiring this application. Now, how you deploy it, how you use it, it all matters. So I'm rushing through that. I'm also bringing into an existing project. This is a building. There was an existing project where the requirement of the client was like what the green box you see. The requirement was, could you help us before we even take up the renovation? Could you tell us what strategy is going to work best? So there's a method called calibrated energy model, in which you duplicate the performance of the existing building on the computer, and the simulated model is behaving exactly the same manner as what the actual consumption pattern is of the energy. Once you achieve that, you are able to study various measures. Like in this case, we studied things like gas engine jacket, water heat recovery, thermal storage. This is engineer's delight, this blue box that you see. The green box is the interior designer's delight, and the red box or the yellow box that you see at the bottom are the questions which were raised by the architects. Each of those questions could be answered where there is a reduction in the air conditioning load, reduction in the energy consumption, the capital cost increase, everything could be studied. There was a potential here for bringing down the the air conditioning load by 300 tons, saving about 3.5 crores in the capital cost, so in the operation cost per year, and the capital cost could also be determined. So here it's a renovation project where the assessments and the study is being done before it is made. I'll bring you to the last study, which is a net zero energy building. The last case study. It's a small building of about 45,000 square feet with only on an 800 square meter piece of land and going 45 meter tall. Now, client was very clear they want to do a net zero energy building out here. Now, to make a net zero energy building, a tall, small building, a net zero energy where we have a very, very little area to put the solar panels on the roof is a challenge. So we started finding out other places where we could put the solar panels on the ground. And you can see here the shadow range, which is casted by the building around the year, a small green trapezoidal area where there's no shadow being casted, being put up for car park. And that's the place on top of it you put the solar panels. studying the solar radiation on the facade, we decided we are going to wrap the building around with solar panels. These are black solar panels, and easier said than done. The aesthetics, daylighting, how does that get balanced out, and the energy was the main challenge of the project. So this is how we are studying the solar radiation coming on the facade year round on all the 4 facades as well as the roof, looking at the solar exposure, the number of hours or day that the solar incident is happening, and then going on to the daylighting. If we do not have any solar panels on the facade, the building is about 96% daylit. Moment we put our solar panels, which you see here in a sawtooth manner, which has been put here, moment we do that, we had this improvement happening. We kept on doing that. I'm not getting into details of it, but it gives you an idea of what has been done there. And ultimately, at the end of the day, when all of the glare and the daylighting was balanced out with the energy, we had 99% floor plate, which was daylit. And we determined various options for putting the solar panels at an angle, the width of the solar panels, the angle of the solar panels, how will they look aesthetically, how will they look in the terms of daylighting, how will they perform in terms of glare, how will they perform in terms of energy. Balancing all 4 aspects, we found out that we could generate about close to 228 megawatt hours, which worked out to an energy performance index of 67 kilowatt hour per square meter per year. Now, engineering is reverse design, where we reverse design so that our consumption in the building matches what the production is. And you can see how step by step is brought down to achieve the generation equal to what the consumption is to reach a net zero energy performance. And you can see the building images on the facade, how those solar panels look, and everybody could do that. So ending my presentation, because since it's a 20 minutes only, I just want to showcase my own office to you. Normally, a green office is always associated with somebody who's going to be a rich corporate, big companies that do their offices as green offices. But we, as a small company, as a consulting engineers, it's a small 10,000 square feet office. We decided to go for a green rating on this. Now, obviously, capital cost was a concern, and the whole digital twinning process helped us in a big way. Today, this office is a 100% daylit office. We don't switch on an artificial light even in our toilet or in the pantry area. Forget about the workspace alone. It has got a platinum rating from IGBC on the green scale, and it's got a second platinum rating on a health and well-being scale, which is another rating system, and probably the only building and the only private office like this, which has have a double platinum rating there. And I can proudly say that all of this came to us at, I would like to say that I saved capital costs rather than spending extra costs there. And the digital twinning process was an important aspect for it. Today, we intend to move it to a net zero energy performance. We have been monitoring the energy consumption in the office, the various spaces, to bring it down. It also has a good air quality. You can see here the PM 2.5 readings and how is it less than 20 so how less than 20 microgram per cubic meter is what we are maintaining out here. We also maintain a temperature of 27 degrees in our office using fans, and these are high volume, low speed fans. We again created a CFD model to see the reach of the fan, how every corner of the room is being covered by it. And when you're running at 27 degrees with a fan with the elevated air speed, one is able to get a feel-like temperature of 23, 24 degrees. So these were all came out of our readings. And today we have about 3 years this office has been running, and we have good, I would say about 95% plus is the thermal comfort satisfaction levels which run there. Our monthly electricity bill for a 10,000 square feet office is yet to cross 70,000 rupees. So in the end, all I would say is that if you look at how the building performance has been moving, in just about 30 years time, what used to be energy consumption building used to about 20 watt per square foot has come down to less than 1/4. It's about 25% of that. Where are we going? Today we are talking about 2.5, 3 watt per square foot for the same building, what same area what we were constructing earlier. And today the buildings are becoming more and more equipment oriented, technology oriented. Look at the air conditioning load. What we used to do 100 to 150 square feet per ton. Today we are talking of 600, 700, 800 square feet per ton for the same space. As the consumption of the building is coming down, and as the generation using the renewable sources becoming more and more affordable, more and more efficient, the gap between the two is becoming closer and closer, bringing us to the next generation of net zero energy building or near net zero energy building. And that's where using these digital twins would make a lot of sense. Future, as I predict, is a net zero resource living. This is what my take is for our power lines, which are running across various cities of India. We can put them to a better use because we will be a net zero resource. Thank you so much for your time, and I hope I was able to keep to my 22 minutes only. Thank you.
Thank you, Ashish sir, for insight into these great green projects. And I certainly feel that we need to start conserving energies and design green buildings so that it's sustainable for not only for us but for our future generations as well. So now moving on. So I'll just share my screen. So moving on to our speaker number 2, Miss Millie Majumdar. So Miss Millie is Managing Director of Green Building Certification Institute Private Limited and Senior Vice President USGBC. In her current role, she is responsible for technical adaptation and customization of the portfolio of rating systems of GBCI for the Asia Pacific region. She is also responsible for customer coordination, education, training, and developing market mechanisms for adoption of the tools and rating systems for the region. An architecture graduate and a building technologies specialist, Ms. Millie has more than 2 decades of experience in the field of energy and environment with a focus on sustainable development of habitats. She has worked tremendously in the sectors of green buildings, climate resilient housing, city planning, and urban transportation. She has a team of professionals to develop a portfolio of green rating systems for habitats that have been widely accepted in India. She has also enabled the development of large portfolio of green jobs through training and skill enhancement. So, Millie ma'am, over to you. I'll just stop sharing my screen.
Thank you very much for the introduction, Farhad. And firstly, thanks Ashish for that wonderful presentation. I think it has set the context. And so my congratulations to Aeon for such good work that you are doing. And thanks Chakreshji for putting together this event. It is so important for us to stay connected in these difficult times. And perhaps this is the time where knowledge can be distributed with digital technologies to all corners of the world. And I hope all of you are staying safe and healthy. And what I would today like to do is I have made this presentation a little generic, in the sense I will not talk about only about the building level, but in general about how tools and techniques and visualization helps us to take informed decisions. And at the outset, as Chakreshji mentioned, that we are going through a tremendous kind of challenging phase, and different parts of the world are facing multiple challenges. So we are blessed to have different tools and techniques that helps us to take informed decisions. And so let us look at what are the different levels at which this can be done, and what could be the consequences of that, and how can we avoid our future disasters, or for that matter, how can we move towards better performing buildings, habitats, and a better place to live in the world as a whole. So sustainable architecture and urban planning, I feel, is a confluence of multiple aspects and has myriads of interconnections. With evolution of technology options, design decisions based on evaluation of multiple options is much simpler and much evolved. There can be multiple levels or hierarchy at which tools and techniques and related visualizations are deployed to address environmental impact of design decisions. We deploy these tools and techniques to visualize impacts of our actions on development. When we look at sustainable architecture and urban planning, there are multiple outcomes that we want to arrive at. So here is a word cloud, which I have picked up from the net, and you will see that different people have different aspirations from the design, and it's going to stay for several years. So how do we make, effective decisions, and how do we make effective choices? So to be able to do, decision making based on more informed choices, we cannot resort to manual means. Hence, the importance of tools and techniques to help us make these decisions. My name is Mili Majumdar, as Farhad has mentioned, and I represent the US Green Building Council. Many of you would be aware of the LEED rating system. So that is our flagship brand, which we take forward in about 167 countries globally. But in addition to LEED, we also are responsible for promoting and taking in the field several other rating systems in the sustainability domain, such as WELL, PEER, GRESB, SITES, EDGE, ParkSmart, and so on. So today I'll talk to you about the benefits of visualization and use of tools and techniques to arrive at sustainable solutions at all levels, be it global, regional, local, and building scale. So as I mentioned earlier, tools and techniques and the visualizations can be deployed at all scales, that is at meso scale as well as micro scale. And the benefits are different at different scales. For example, if you do a global climate model, it can be used to assess global impacts of climate change and the associated issues. Outcomes of such models can help us in assessing future risks and vulnerabilities and take actions. On the other hand, tools and techniques deployed at city and urban planning scale can help us with things like street geometry, shading, massing, orientation for achieving better comfort and energy efficiency. Planning at neighborhood level, which is more micro scale, can help us to address solar access, wind flows, impacts of urban heat island. And many of these things Ashish demonstrated on how he has done it at different scales. Renewable energy integration and so on and so forth. At building level, as was mentioned by Ashish, that we do whole building energy modeling as well as system level modeling to achieve energy efficiency and high performance buildings. Let us first begin with an example of climate modeling at regional scale and their impacts and associated actions that we can take to avoid future disasters. And these days we are seeing that disasters are hitting us, all the time. Recently, we had Amphan that hit West Bengal, and there was so much amount of destruction that happened. So this is an example of a regional climate model for a city in northeast part of India. And you will see that the model here, the regional climate model, is able to predict the temperature rise and its trend over several years. The model is also able to predict extreme rainfall events and the chances of flooding in that region. And this particular city, which is Guwahati, also has the large Brahmaputra river, which flows through it, and it is flood prone. And so it is it's one of the regions with the agriculture dependent economy. With this predictive analysis and specifically with future predictions, one is able to visualize the changing temperatures and the risks of flooding. And this helps us to take actions on ground level as well as at policy level to avoid consequences of things like temperature rise or urban flooding. For example, if I say, how can I use this model to inform me about the future of agriculture and the changing temperature, so I would definitely know that my temperature would change over the years, and that will have results in crop yields, physiology, growth cycle. The farm system will face soil erosion in future due to flooding. That will impact use of pesticides, fertilizers, etc. And there is a much larger impact also on people, on incomes, on livelihoods, migration, displacement. And we have seen all of these grappling us in this recent time. So we need to be better prepared for future. And overall, it will have an impact on the food system. But if we are able to do predictive planning exercise and visualization, we can take advantage of the actions now so that we can avoid these impacts in future. For example, we can talk about differential cropping systems in different seasons, taking actions on ground to prevent soil erosion, adopt overarching policies for migrants and displaced population. So tremendous impacts of tools, techniques, and visualization. Now let's move to a little smaller scale. This is an example, and we are aware that Japan is very, very technology, savvy, and they are able to use different predictive tools to help them battle disasters. And we know Great East Japan's, tsunami that happened a few years back, and the nuclear disaster that happened. And that helped the country to bounce back and, resort to smart solutions and visualization techniques and predictive analysis for disaster management. They are much better able to predict earthquakes, early warning, and that is helping them to be better prepared. And they have deployed techniques such as relocation of residential zones to higher land, smart mapping of roads that are passable if disaster strikes, processing of rubble and solid waste, and so on. Next, let us look at even at a little smaller scale. For example, let us see how climate mapping at an urban scale and its visualization can support better urban planning. This is the case study of the new development of Marina Bay in Singapore that took advantage of visualization using multiple tools to arrive at an urban morphology and overall urban design. Elements were designed. The planning team carried out air temperature, wind velocity, thermal comfort modeling, and then the outcomes of the modeling helped them to plan for additional greenery at street levels, as well as incorporation of urban design elements such as sky gardens, roof gardens, staggering of building geometry, modulation of building heights. All these measures help the development to achieve desirable higher wind speeds at and around the staggered levels, improve thermal comfort due to better wind velocity, reduced air temperature. This also has an impact on energy consumption and overall thermal comfort in the development. Now moving on to the building and campus level, which many of us are much comfortable with. So we know that architects and designers, particularly the ones who are in the practice of sustainable design, they adopt integrative design process, and Ashish highlighted that in his talk many a times, and are able to do value engineering by using different tools and techniques and achieve a design that is green and sustainable. And this offers the best value for money, because finally at the end of the day, cost effectiveness is crucial. So the earlier you start the value engineering, better it is. Typically in an integrative design process, the value engineering and use of tools such as building information modeling begins at very early in the design stage. This gives maximum benefit. However, if you choose to do a linear design process, then you would have lost out the value engineering opportunity that you would have otherwise gained. So when we talk about the integrative design process, so essentially what happens is, what is the concept? The concept is that, we have a client for whom we build, we have a builder who constructs, and a design team, rather a multidisciplinary design team that contributes to the design, and each of them would have an input to the design. And sometimes what happens is that the inputs may clash. For example, as an architect, there is a notion that if you have more glass area, then the building would look better. However, that may have an impact on the energy consumption and the MEP design. So you have to have a balance. And now if you have to involve so many actors, which are shown in this diagram, and take inputs and make decisions which is best for the client, then you cannot resort to manual techniques. You have to deploy multiple techniques and the integrated process. So let me show some example. And here I have talked about specific case study where architect and landscape architect came together to make some informed choices. So this is this is a case study for a housing complex at a neighborhood scale for a corporate campus in Andhra Pradesh. The design team had to deliver an efficient design and minimize, or rather moderate, the air temperature within the campus and offer a better microclimate. So what was done was a detailed urban heat island study using computational fluid dynamics was carried out. Ashish spoke about CFD several times in his earlier presentation. The base case comprised of hard paving and asphalt roads, and the CFD analysis showed that at about 1.2 meter level, on a typical day during March, the average late afternoon temperature on the campus shall be 39 degrees Celsius. And even during early morning, at 4 o'clock, it shall not go down below 31.5. So there was a lot of heat getting trapped. Obviously, this kind of an outdoor design, the design team cannot achieve the objective of a better microclimate. So what happened? The architect and the landscape designer, they got together to design appropriate landscape vegetation, and was able to reduce the average temperature and the early morning temperature substantially by about 3 to 4 degrees Celsius. Subsequently, the architect wanted to take advantage of that reduced microclimate temperature and facilitate natural ventilation in the houses. So what did he do? Further analysis was done to map the wind speeds at different heights of the building, and the architect then used the results of the design of the output to design things like intermediate courts, bridges, etc., and took advantage through natural ventilation. And as soon as you switch buildings to natural ventilation, you can reduce air conditioning load and consequent energy consumption. Now, we spoke about, different elements of the design. So finally, the design, the building has to perform, and which is a culmination of multiple design inputs: the electrical design, the lighting design, the water system design, HVAC design, architectural design, and the control. So everything has to function as an unified whole and give the best performance to the client. So this is a framework, and so which captures that how an integrated energy modeling exercise happens. So in the centerpiece, so you have a final end goal, that what is it that you want to achieve. Your end goal are twofold. One is that you want to have the best of energy performance, but you do not want to compromise on the comfort. The comfort are thermal comfort, visual comfort, acoustic comfort, and indoor air quality. So these parameters are fixed, and you have to lower the energy performance of the building, or rather not lower the energy performance, but lower the energy consumption and improve the energy performance of the building through better lighting design, integration of daylighting, building envelope, and a better air conditioning design with controls. And then once you have an optimized design, you will feed in renewable energy systems and try to move towards a net zero energy building, So that's the whole concept on how this works. And we use different tools and techniques and visualizations to make it happen. And it is not the task of only the architect or only the MEP designer. So everybody has to do their part. And the sustainability design consultant finally aggregates all of this to produce the end results, which is a better energy performance. So what happens in this exercise, and the earlier we start the process, the better it is for the project. At an early stage, we can restrict to things like, say, simple box-based analysis and visualization to make macro decisions related to building geometry, massing, orientation, window to wall area ratio. So I just want to tell you, do not switch to things like CFD, etc. in the beginning. They are good tools, but then it requires a lot of expertise to operate them. It can simply be garbage in, garbage out if you do not know how to operate them, properly. And so there are experts available. So, and I think Capricorn also has the BIM solutions to help designers in these aspects in a better way. So, and whole building energy simulation should be done at a later stage, because often it is a very rigorous exercise. So when we talk specifically about the actions, so we start with basic elements of architectural design, such as related to massing, orientation, window to wall area ratio. For example, you can see here there are 4 different floor plate typologies, but every typology has the same floor area. But the window to wall area ratio, changes because the shape is changing. So then you can deploy initial tools and techniques to find out. So for everything, you have an end goal. Here, your exercise is that how you're minimizing your specific, envelope gain. So here, through basic analysis, you find that the H shape is having the, specific envelope gain that is lowest. Then you can take a design call. After that, you can further do, micro analysis to see that from which part of the facade my heat is coming in. And then you optimize that. And this also can end up in having you choose the right kind of insulation as well as the glazing typology. We can also carry out exercise for optimizing orientation. And for the same form, we can see if your site offers an option that how you can rotate your building and which orientation gives you the best results in terms of least energy consumption and least cooling load in a hot climate. So these tools and techniques help you. Similarly, you can do optimization of window to wall area ratio. However, in this case, it is obvious that if you have a lower glass area, you will have a lower cooling load. So the decision on window to wall area ratio is dependent on another very critical variable, which is daylighting. And window to wall area ratio and choice of high performance glass is decided based on daylighting, energy consumption, and overall cooling load. And of course, cost effectiveness. And the tools and techniques and visualization also help us to look at impacts of multiple design decisions in an integrated manner. For example, in this particular image, the comfort hours are represented as percentage where a point in space meets or exceeds a given set of thermal comfort acceptability criteria. This is a 3D exploded axonometric view of a 4th floor in a building. And we have two options here. One is a base case with about 30% window to wall ratio and the other with 45%. And this kind of representation can help an architect understand the perceived impacts of various elements used in the building envelope. Similarly, I can go on, but then I have to restrict since it's a restricted time, that we can do shading device optimization with an end goal of providing maximum shading for better thermal comfort, but also maximize daylighting. These are some examples, of great architecture where these tools have been used for optimizing shading. On the right-hand side, it is the mist building of the Masdar city, which is a famous building by Norman Foster, and it is designed in a hot climate to protect the spaces from getting harsh sun. Now coming to the other important aspects of lighting design. So what has happened is that lighting design has evolved over the years, and optimization techniques have changed, and hence we need to use the tools and techniques in a much advanced way now. And you have different kinds of lighting software that can be used to design multiple schemes, and we can take action based on efficiency, aesthetic value, and cost. And while doing so, daylight modeling and study of daylight availability for reducing energy consumption is done to achieve a better and an efficient design. And it is also possible to visualize daylight availability in spaces and integrate daylighting with artificial lighting through control strategies. I'm skipping, the things that we can do with HVAC modeling, because that's another area of optimization. But finally, as I mentioned, you do it in parts and then you have to synthesize. So finally, when you carry out the whole building modeling and derive benefits from optimization carried out in envelope, lighting, HVAC system, the end result gives you a high-performing building. And you can actually see the journey from where you started and where you ended, and the kind of savings that these tools and techniques have given you and the visualization you have achieved out of it. So it's a very, integrated process, and it is time consuming. But at the end, the result is very fulfilling. Now, we are talking about design, right, all the time, but you really don't know. As architects, we design and then we do not really go back and check that whether the building is performing. So it is equally important to visualize the performance, whether what you have designed through all the simulation, CFD, whether it's actually working how you did it. So continuity, visualizing performance and ensuring continuity and improvement is something that we promote a lot these days, and LEED has a tool to do it. In LEED's new, rating system for operation and maintenance that applies to existing projects, here what we have done is we have created a cloud-based platform that helps you to culminate all your design parameters and quantify them through an energy performance through monitoring and recording. So this platform is called ARC, and this is the website, and I'm not getting into the details. So what you do here is that you input your performance data on 5 performance parameters: energy, water, your indoor environmental quality, transportation, as well as on your waste management. And you are able to track data and see that what you had committed at design stage, whether actually you are performing to that level. And the tool gives you a performance score. And this is dynamic. The better you perform, the score also improves. And it also gives you cues on things that you need to change, and if the building is not maintained properly. So that is very, very crucial. For example, in our office, which is in Noida, So we have a performance dashboard, and we also measure the indoor air quality. So here you see on the top screen, some days when perhaps the outdoor air quality is bad, we have a slight shift in the indoor air quality. We are not, maybe in this case, getting the requisite quality. However, we go back and check whether our systems are operating properly, whether the filtration is correct. So this helps us to visualize performance and take actions, which is very, very critical. And this particular platform also helps you to do analytics, and most importantly, set goals for future improvement. There's always a chance for improvement in performance through tweaks, through maintenance, through upgrades, and this tool can help you to track that. For example, this is an Ascendus Pinnacle building that was initially certified to LEED Silver, and it moved its performance to gold by making tweaks in its systems, lighting, air conditioning, etc. So it's a continuously improving, design. So I just want to end by saying that when you visualize, then you materialize. So all these tools and techniques are very good for you to visualize, and we all want to do that. And when you materialize, you have to maintain what you have visualized throughout the lifetime of the building, because that's the enormous footprint that it leaves behind. And you can do that. So I think it's a continuous journey, and we can make this happen with the help of modern tools and techniques that we have. Thank you very much for your attention.
Thank you, Millie ma'am, for giving us such a broader outlook of visualization and sustainability. I myself, being the urban designer, I can relate to city information modeling actually, so that at city level also our data is integrated and coordinated for a sustainable city and a nation. Plus, I really like your point. Passive measures are the best. So I really press on that architects should have the tools at conceptual stage itself, so that, because the passive measures are very cheap and they are very effective and there is no maintenance. So we have Autodesk Insight for that. So the simulations which you showed for the audience. So that was really helpful, ma'am. So now moving on to Miss Priya. I'll just share my screen. Okay. So our speaker number 3 is Miss Priya. So Miss Priya leads Autodesk Sustainability and Foundation, India. And as part of the role, she reaches out to many Autodesk customers and stakeholders to advocate and enable the common goal of carbon neutral and climate resilient built environment for all. Her day-to-day conversations with these stakeholders include how technology can effectively integrate business and sustainability. And an ecologist by training, Priya specializes in urban water and wastewater systems. She brings in with her a decade-long professional experience in dealing with market feasibility, community-oriented technologies such as decentralized drinking water systems, process optimization, and energy efficient solutions. Ms. Priya is a doctorate from University of Karlsruhe and is passionate about causes concerning natural resource management and spirituality. Over to you, Priya ma'am. I'll just stop sharing my screen.
Thanks, Farhad, for the introduction. And thanks, everyone, for joining us on a Friday afternoon. As compelling as the topic is, we've had wonderful insights from my speakers prior to me, and it's amazing to hear their insights from their vast experience. So I wouldn't. It would be redundant to speak on the same topics. But having said that, I would like to do my best to summarize what we, as a group of experts in the sustainability and the AEC space, are trying to talk about on sustainability. I'll do my best to summarize what is called as a collective voice that I would like to believe that. So let me know when you get to see my screen.
It's visible, ma'am.
Thank you so much. All right, so I'm Priya. I lead the sustainability initiatives for Autodesk India, extending the support to the rest of the APAC as well. And thank you, Mr. Jain, for bringing us to the reality of the world that we live in. I share your thoughts, and I would like to reiterate that again. The world as we know it is changing, and we are a growing number of people, which means we would be looking at more number of buildings to host us and a supporting infrastructure to support us, right? And when you're talking about more buildings, more supporting infrastructure, we are also talking about more materials and natural resources, and also in the form of energy, not just to build this infrastructure space, but also to operationalize it and sustain it in years to come by. That's a huge task that we have called upon ourselves. And
Ma'am, you're on mute.
Yeah, so this calls for the way we look at things in terms of we at Autodesk are cognizant of the fact that there will be more in terms of demand for products, more in terms of demand for cities, more in terms of buildings and every supporting infrastructure. So more is inevitable, but also the fact that the natural resources that we would need to build this ecosystem for ourselves is depleting. It's also limited, and so less is a reality. But speaking from a design perspective, this is also an opportunity to do better. Right, better in terms of a better future for ourselves with less negative impact on our environment. This vision statement, or this idea for us, has come from the fact that probably all of us here in this space agree that what I'm about to share, that 90% of products' environmental impacts are determined during the design stage. That is as early as drawing board stage, right? So the speakers prior to me did emphasize on it, that the early you get to understand your design, early you get to understand the environmental implications, the better it is in terms of not just your overall project performance, but also very importantly in terms of achieving your business goals, achieving your project timelines, and overall ensuring your business outcomes and sustainability outcomes. So this is just a graph that proves my point. And also we've had customers like Mills Group who have, with whom we engage with on solutions such as REVIT and Insight, right, which help them conceptualize at a very early stage, anticipate the cost, anticipate the challenges that the project could have, in terms of energy, in terms of physical space challenges. And this helped them also have a very open conversations with their customers too, and gain their trust. With customers like Mills Group and many other customers globally, the work they do inspires us. Their ambitions, the way they are embarking upon their sustainable journeys inspires us. And today, when our vision and a mission is to enable and help people imagine, design, and make a better world with less negative impact. And what we have done with this mission statement is sustainability as an overarching concept. We believe that through our solutions, through our customer conversations, Autodesk can directly impact or create a positive impact in 6 areas of what we call as impact areas of opportunities. Energy and materials, in terms of how can we improve energy efficiency in your production process, or how can we help you choose the right materials and the right energy strategies for your buildings? How can we enable and empower our customers to create a healthy and resilient building? And most important of all, how can we as a design tool company engage with you, partner with you as a customer to prepare you for the future through our future of work and prosperity conversations? And while doing so, we're cognizant also of the fact that there are multiple standards that in organizations such as IGBC and GBCI and also the UN SDGs, which are helping every one of us to align our sustainability goals in a more structured way. And Autodesk also aligns our sustainability goals very clearly to these 17 development goals. And very specifically, we believe there are 6 areas or 6 goals that we focus particularly on to maximize our positive impact. Energy, economic growth and decent work, industry innovation and infrastructure, sustainable cities, responsible consumption and production, and climate action. What we have also done is we've looked at all our customer base and the sectors they operate within. And we mapped these 17 goals against these segments and have started looking at driving some of these UN SDG conversations with our customers. A snapshot of how we lead with example while we are engaging with our customer. So this is a highlight of our 2020 sustainability report. I'm happy to announce that 100% of our office and data center, the electricity powering our offices and data center comes in from renewable sources. And also that we have seen a stark reduction of 43% from our previous year in terms of our global greenhouse gas emissions. We have taken this success and created ourselves a higher target of creating more climate neutral emissions by the year 2021. Very specific to our solutions, while we are looking at how we could streamline our own initiatives, our own lead with example, we're also being very proactive in creating more sustainable capabilities in our solutions. Most of you are aware of CAD as a primary platform for your design, for your design initiatives, for your design requirements. But we've also looked at, we are also known for our REVIT. We are also known for our BIM 360 solutions and our generative design capabilities that we are talking about, both for the AEC and the design and manufacturing space. In similar way, these solutions are aligned to helping every customer of ours to create high performance building design, or adopt lean construction practices within their projects, or in fact, taking a step away from the buildings and looking at a larger neighborhood. Our solutions are also there to help our customers create more sustainable, resilient communities and smart cities, smart and sustainable cities. What really helps us and what really drives us is each one of you, each one of our customers. And we've seen that over 50% of our customers are driven by sustainability, and they have all pledged their alignment to the UN SDG goals, or even Architecture 2030, energy goals as well. And we are observing, we are keenly looking at how the markets are aligned, how customers are looking at not just the current trends, how can they pivot more towards sustainability. And there are these factors that are driving them: cost, compliance, clients, of course, the consciousness to do good, the consciousness to create a better world, right? And there are market trends which are picking up. They're like Mr. Ashish said, net zero buildings are gaining more prominent. We are looking at creating more carbon neutral built environment. We are looking at construction processes which are more circular with zero waste construction. You'll be most of you are aware that the construction as an industry contributes 30% of global waste. So, and if we are looking at building or close to 5,000 or 1,000 and above buildings per day to support our growing human species, then you can look at 30% of that construction going in creating a waste everywhere. Addressing that becomes imperative. And we are all, with buildings, they soon develop into cities. So yes, there is also a much growing trend for the need for smart cities and infrastructure, not just in India, but across the world. Quickly on to what do we mean by high performance building design? I would not be talking about anything into details of the technicalities. Ms. Millie and Ashish had already shared that quite explicitly. So I would just show, or rather give you an overview of how Autodesk or technology as as an important and vital tool can help architects and designers to create these or analyze your building performances. So basically, we are looking at, of course, passive design strategies. We're talking about how can we integrate renewable energy sources within your strategies? How can we look at optimizing building systems? Very importantly, I believe somebody did ask a question in the chat. When you are looking at energy strategies, is energy, how important is material choices? It's as important. Energy and material choices would go together, and perhaps Ms. Millie would be is more equipped to handle that question. And when you're looking at these solutions, how you would need a technology solution that would help you analyze your entire design strategy holistically, not looking at independently in isolation, but rather the entire system, gives you a systems approach, a systems orientation, and give you an entire building analysis together, with again mapping against standards such as LEED or even AIA 2030 or ASHRAE, right? It will help you analyze solutions with like format, right before you start putting up your building. When you are at a barren land and you're looking at what would be the right, when you are exploring the design options, right? Format, REVIT, and Insight are your tools to put together your whole building and energy analysis, your details design analysis. And of course, you're looking at cost comparison and performance information across your design options. So while your system is is at its job, giving you the design option, you as a designer with your deep thinking and your expertise would be doing what you are required to do. Pick the right option for your client. And a step forward into, again, not going into detail, we're looking at facade and HVAC systems do play a vital role in your entire energy footprint, right? Here again, tools such as REVIT, Insight, and even CFD for that matter, helps you create first create the entire model for that model. Look at the analysis or drive a simulation and analysis holistically. Understand what are your solar loading aspects, what are your what's your thermal comfort at that point, depending on the design that you picked up. Or even when it comes to safety, how do you optimize your your system design, that you have how can you carry out a contaminant and a smoke analysis within your building design as such. while you're looking at, like I said, energy is one aspect, and material choices is also a critical factor. So embedded within these tools are also gives you a whole range of materials that you can play around with to check how each of those material choices will impact your energy footprint. DPS, which is a global customer of ours, we've engaged with them a couple of years ago. We've impressed upon how these technologies or early stage analysis and simulation would help them analyze or create a better design options for themselves. And they were happy with the result. They were looking at 48% energy savings over their baseline, right? And that created a huge savings for them, almost 2.5 million USD with net zero. So like DPS, we have other customers in India and also globally that we are working with allowing them to do an early stage design analysis, conceptualize, include simulation analytical at a conceptual stage to come out with the right design outcome. Moving on to healthy buildings, yes, again, we are looking at heat gain trade-offs, daylighting. We have solutions such as REVIT and Fenestra Pro with CFD, which will help you analyze your, quantify or balance trade-offs, or even room airflow analysis, ultimately looking at what is the best thermal comfort assessment that you can embark upon, and what is the best thermal outcome that you can give for your residents. I'm going to swiftly go through this, respecting the time frame that we have. So when you're looking at CFD, it basically looks at your modeling, your primary modeling, which looks at internal obstructions. And also at the second step, it looks at your air volume analysis, creating what the external air volume is combined with your internal and external flow factors, and then simulates and creates a mesh, runs a simulation and gives you the best performance based on the results or the parameters that you have fed in. Here's a case study, Botanical Institute of the university campus, and this building was as old as 1935, and over the years the building kind of got renovated, and what they realized is they started losing the natural ventilation that the building had, and soon the comfort and the airflow dynamics within the building was lost. So what we've done is we've helped them scan the building and bring them onto the BIM model and run the CFD simulation for them, which gave them the the options to renovate the building to have better natural ventilation and daylighting, bring it back into their building. Moving from design, I would now step into the whole lean construction space. What is it that, what are the principles of lean construction, directly aligning to the UN SDG goals of industry innovation and infrastructure and responsible consumption and production. Here's an example of a Dutch company, Van Binion, which is into the space of creating standalone sustainable houses. Here are each of these buildings are off the grid. They are self-reliant and they're standing in their own space. We have invited them to the Autodesk University, where they had attended a couple of training sessions on our solutions. What they have done is they have used the prefab or modular construction principles and the lean practices and recreated their entire building model or construction process. So what ideally takes about, it used to take for a few months to weeks, they were able to put together, manufacture the various parts of the house, bring it to the site and put it all together within 3 days span. Imagine the amount of rework that they were able to save. Imagine the amount of a material pilferage that they were able to control. Sustainability doesn't feature just in terms of the best designs that are out there, but also it simply means how much of savings in terms of, you know, the energy, material, all boiling down to the finance or the costs that you're able to save for the project. That's also quite sustainable. And just a bit on the principles of lean construction. We're looking at ultimate result is to minimize waste and of course maximize efficiency. What are you looking at the pre-construction phase? How well can you collaborate? When you have multiple stakeholders, how can you bring them all together on the same platform? How can you coordinate with them better, streamline logistics and your scheduling process? And on site, how can you avoid risks, of course? And very importantly, how can you avoid the rework and reduce waste, manage risk? With industrialized construction, of course, you're talking about more lean production, productivity, and improving in the efficiency aspect. Tata Reality was one example that we worked with in the recent times, where they had this huge ambitious project in Gurgaon. And while discussing with them, we did talk to them about how are they looking at, you know, lean construction and adopting lean construction principles. And when we started working with them early on, and they were able to see that they could save almost 30% of their costs in the construction project simply by addressing simply by addressing minimal waste, simply by removing waste and a better coordination. At the end, I want to just leave with this video an example of a hospital and the Nordic Office of Architecture. What they have done is they've created a BIM model of an hospital where there are unique aspects of the design, of course, that needs to be constructed and plug and play, but there are also similarities in terms of each of the room in the hospital is similar to one another. Imagine looking at this as a Lego play. We just plug and play each of the common systems, and wherever there is a unique factor, we manufacture it and bring it to the site and fit it there. Generative design is also the concept that would help you, remove the redundancy of the sketch work, the manual work that is required out of the designers and architects. While it'll put together, while the machine, it's a combination of the human mind and the the machine learning, and helps you choose from a different options. So where the human mind and its imagination ends, the machine picks it up from there, stretches the imagination based on the parameters that we feed in, and helps us pick the right option out of it that fits not just into your business, but also your sustainable outcome. End of the day, this is something that I want to leave you with. Yes, the idea is to create a better world, but also in order to do that, it's a technology as a tool, as a solution, plays a vital role. It's also a way for us to look at it as we do what we are best at with our deep thinking and our expertise, but let the machines help you be better at our own jobs. Thank you so much.
Thank you, Priya ma'am, for introducing our audience with the green initiatives and tools available with Autodesk. Now I can see actually a lot of questions coming out, especially on how to learn these tools as well. So I would just share, just take 2 minutes. I'll share the solution for that, and then we'll move to the question answer session. So at Capricorn, we have a program, BIM for Design, and it's focused on the design workflow and project delivery using BIM tools. It's not about tools, it's about how the project to be delivered with the help of tools. and we take up Revit Advanced, Navisworks, BIM 360, then Dynamo Format inside, which Priya ma'am was also talking about. And if you have any query, then you can mail on training@capricot.com. We'll get back to you. This is for the individual professionals basically. And if you are a corporate or the office struggling with the implementation of BIM, you already have Revit, but you are not able to produce result, then we have a program, BIM Guru, for architects or the offices. And as it says, it's as your trusted design technology partner, Capricot has introduced a simple and comprehensive program to provide training, troubleshooting, and content library to support your team in confidently delivering high quality and on-time projects leveraging BIM. So basically, it's focused on BIM implementation for design consultant. Then it's a 1-year service contract and 40 hours of tool training and online troubleshooting of 50 hours, and Revit content is there. And then you can email on bimguru@capricot.com if you have any queries for that. So we can give you the demo key how this product can be delivered to you, and you can be tension free, stress free. Your team can come back to us and we'll help them implement BIM in the project. So that was about these training programs. And one thing I want to add more, that next week on 10th of July we are having a very good event. The topic is how to run a virtual design studio. Now COVID is a burning issue, and everyone is thinking, especially the architects, how to collaborate online because it's very tough. So we are going to show you how the industry stalwarts are doing this. They are literally collaborating from home and with better efficiency. So it's on next Friday, same time, 3 p.m. to 4:30 p.m. And if you want to request for registration in advance, you can email at connect@capricot.com. Or if you are already a client of Capricot, then you will get the email. So now, thank you for sparing me 2 minutes for that. Now we'll start the question and answer session. So I can see a lot of questions in Q&A box, and if because time is limited, if the time is over, you can mail your questions at connect@capricot.com, and for training queries at training@capricot.com. And even if you are not able to answer, we are going to reply back. So you can just mail it, and then we'll get back to you with the detailed answer. So I'll start with the questions. So I'll first try to cover the questions in the Q&A box. So 1 second. And I can see a lot of hands raised. So first I need to cover the question in the Q&A box. So so it's from Ms. Rashmi Casey. And how would BIM help me capture data for green building certifications? So already Nazim has answered that there are BIM software which compares a model with standards. Priya will be discussing it in the further webinar. So I think Millie ma'am is in can answer this, or maybe Priya ma'am can answer. Yeah, Priya ma'am, you are there?
Yes.
So the question was, how would BIM help me capture data for green building certifications process? So if you can just.
So yes. So when you're working on tools such as Revit, creating your design there, the either the architecture 2030 standards or the ASHRAE 9.0 path meters, are already embedded in terms of the for your energy footprint analysis or your material choices. So when you are going about designing, it will when you are you have the solutions have the capability to create those simulation. You can simulate your design and see how best your design can adhere to your to these standards too. And whether it is end of the day, with whether it is GBCI or IGBC, it's the building science as a principles which are there. So if you're looking at how these sustainable building science principles are, how your design is adhering to these principles, you can create these simulations within Revit. I hope I answered the question.
Yes, ma'am. Thank you, ma'am. So next question is, will I be able to do Win module and integrate the simulation models into BIM? Sure, obviously BIM allows you to do the wind analysis on your model, and Priya ma'am also displayed, I think, CFD analysis in some
Yes. So
related software.
the example that I had given, that was a perfect example for retrofitting an old building that has, kind of changed its design, or your natural ventilation that impacted its natural ventilation aspects. So you have a capability. We do have a solution that would help you scan your model with your building, put it onto a BIM model, and run your CFD simulation for your through this BIM model as such.
Thank you, ma'am. Then we have a question from Mr. Neeraj Verma. Please mention the name of software used to do all these simulations. So Priya ma'am also displayed certain software. We can send you the list of the softwares which are there in the Autodesk solution. We have your email ID. Then this is from an anonymous attendee. What tools are used to generate the kind of simulations that were displayed for CFD, indoor lighting? What kind of data input is required to generate realistic simulation? So yeah, Autodesk CFD is used for running simulation of the BIM, Revit and Insight for lighting, solar analysis. Inputs are required, location, lat long value, building orientation, various material. So these are all the parameters. Okay, so these are the questions already answered. I think I'll go to the open questions. Nazim has answered most of the questions. Does material impact on or the orientation of the building impact on the thermal performance of the building? So this question is from Mr. Bhupen Patil. So I think this also Priya ma'am answered in her presentation. Obviously, yeah. I think you referred to this question, right, ma'am?
Yes, I did.
Okay. Then can sustainability and model construction go hand in hand? From my point of view, yes, it definitely will go hand in hand. In fact,
The Van Winian, the example that I had shown, the Dutch company which looked at creating sustainable standalone homes, was all done through the prefab or modular construction process.
okay.
So perhaps we'll be happy to share some of these stories. I think you can later share it with the attendees as well.
Sure, ma'am. Sure, ma'am. And then we have question for Mr. Ashish by Mr. Ravi Kumar. So Mr. Ashish had to leave actually. He had to attend one more online event. So Mr. Ashish, can you elaborate about the high volume, low speed fans? Are these manufactured in India? What is additional capital cost and advantages using the same? So we'll get back to you on this answer. We can mail you. This is a very specific question. What are energy modeling CFD thermal analysis tool used by you, and whether Autodesk tools like CFD energy modeling are acceptable by USGBC and IGBC? So this is an interesting question, ma'am. So would you like?
I can't answer whether CFD Autodesk CFD tools are accepted by IGBC or GBCI. This is something that Ms. Millie and Mr. Rashi should be talking about. But what I can say is, as the design tool company, right? We try to create solutions that are, which obviously follow a very scientific method, aligning to the global standards, at the same time ensuring that it is all based on the building science principle, right? And all the standards, whether it is GBCI or IGBC, of course, they also follow the same parent, models at the end of the day. But having said that, I would rather have the question being answered by Mr. Lee here. But going by my experience with our customers, whoever are, they have, most of our customers go with the LEED certification, and they have successfully used our tools to see how best their design options are aligning to the LEED principles or LEED standards as such. So we have studies of how Autodesk solutions can help them, help our customers align with the LEED standards of principles.
Right. So, plus to get Millie Ma'am's point of view on this, we'll
Yeah.
mail back the answer when we get it from her. So then we have question from Oves. Since we have seen energy has direct relationship with the climate change, are we limitizing or restricting energy usage for different types of building, or do we not think we should limit energy and push towards green by policy?
Well, valid point. It has to go both. As in, there is, when you're talking about developing buildings, right? And there is the larger stakeholder influencing conversations at the policy level. So the work has to happen at both the ends. While the government or the decision makers are putting in their effort in, you know, um, creating more need for data centric approach, need for a better process alignment in the infrastructure space, need for a sustainability policy as such, right? In the infrastructure. It is also imperative that the people in the industry, people in the construction space, take up voluntarily some of these initiatives and integrate these sustainability principles in their project. So it has to happen on both ways. Uh, the valid point of resilience, yes, we are looking at climate change is not, or flooding is not restricted only to the coastal regions or cities anymore. There's more instances of uh, you know urban flooding in the cities away from the coastal region. It's more common now. So all the more imperative for us to see how are we designing our buildings that are more resilient to the changing environment.
Right. So I hope that answers the question of Mr. Oves. Then we have a similar question which was asked earlier. The daylight and energy simulation results from REVIT are acceptable in IGBC or USGBC. Now I personally want to here highlight one thing. Look, REVIT, even and any simulation you want to do, energy simulation, you need a virtual asset, and for that obviously you will have to use Revit. So Revit is the data collection. Then you do perform the analysis. Now that analysis report is obviously it is accepted by IGBCs and UGBCs. But anyhow, to start your now what is happening right now? Architect is working in 2D, and then the 3D consultants, they have to make the model from scratch. Instead, the architect should work in Revit and provide the model to the energy consultant so that they can easily run simulation on the building, on the virtual asset, and this will help in doing the rework again.
Yeah, adding to Farhad's point here, I agree. It's definitely a comfort zone to work on a 2D platform. Of course, everybody is not on 3D. I completely understand. But when you are looking at working on concepts such as high performance building design and or your energy footprint or carbon footprint for that matter, um, as an architect, I would rather see it. I am not an architect, but as if I was in an architect's shoes, I would rather want to, see how my design performs before I show it to my client or before even I take it to a consultant. I would want to have a better understanding of how, what are my various design options, considering the final goal of an energy footprint or a carbon footprint for that matter. So it, and like Farhad said, the entire process right now is the changing from 2D to 3D, and the kind of a date, or even moving from one platform to the other platform, the kind of a data loss that happens, the kind of a rework that happens. There's so much of time that is getting lost by going to and fro. So our idea is to minimize that time, minimize that to and fro or a rework for our designers and for our architects there, and equip them with the simulation and analytical tools that help them to design, analyze, simulate, and analyze on a single platform. I hope that answers, that
Yes,
the
ma'am.
question.
Right, I completely agree with you. Then moving on to next question by Mr. Ravi Kumar. Miss Millie, are any considerations of pandemic-proof design being included in lead roles for building certifications? I'm not sure. Currently, world is out looking for the vaccine first. But if there is any, then I'll get back on that on email. Then, as an architecture student, is there any benefit of doing LEED certification in India by Vasu Vardhan? Obviously, yes. Uh, you should do some certain kind of certification, because when you're working for the architect or energy consultant, there are few points for the person, for the team also. So like in IGBC, there are a few points. If you are a lead certified professional, then you get additional points. So yes, and it's a good, you can say, strategy to get a good job and high pay. Then, Mr. Ovais Khan, are we going to include minimalism in green rating system? I assume not, Ovais. But minimalism is the architecture style. Yes, I also agree that we can, make by removing the unneeded things or the extra things. I also, like minimalism. So, yeah, obviously, if you use less thing or the required amount of thing, and that is going to use less energy, and less energy means better sustainability. Um, then we have, are there any building construction waste management certificate course to learn to help reduce this problem in India? I'm sure there are, and I can, mail you the list, Mr. Somak Sen Gupta. So that was the questions. I can see one hand raised from Nida Shakil. I'll just allow you to talk. Nida, you are like, you can unmute yourself if you want to ask something. Okay, I think that is by mistake. Then, okay, that was all the questions. So, uh, thank you everyone for making this event a successful event. Thank you, Priya ma'am and other panelists. So, please remember that we are going to have one more other event next week on Friday. And if there are any further questions, then obviously you can write to connect@capricorn.com. And if you want to get trained on the software, then training@capricorn.com. Thank you, everyone.
Thank you. Thank you for
Thank
having
you.
me. Farhad. Thank you so much.
Thank you.